Today we are going to write in an inequality to represent the graph, and also graph some inequalities, practice doing that again, and then in addition we'll do some review problems, writing equations and solving systems of equations. And so let's take a look at the first set of directions. It's going to ask us to write an inequality to represent the graph. So the graph's already there, we just need to figure out how to write the inequality to match it. Well, all you have to do on these problems is look for the y-intercept and the slope. And then from there you can figure out which way to end up shading it as well. And so we'll start with that y-intercept. Here I have a y-intercept of 1. So it crosses at positive 1. So that's my y-intercept. And then I'll look at my slope. Now the slope of this line, if I just start at this point here, this y-intercept, and I go to the next point. So I'm rising to the elevation where it crosses. And it looks like it crosses right here. It's going to cross right here and right here. And so what I'm doing is I'm going up 1 and then 2 to the right. And so it's a slope of positive 1 over 2. So from there, all you're doing is using that slope-intercept form. Y equals mx plus b. So all we have to do is write in the y-intercept, the slope, and then you have to figure out what inequality goes in place of the equal sign. And so we'll go ahead and write this out. Positive y. Now, look at the inequality here. This is a dashed line. So that means it's either going to be a greater than or less than. So it's one of those two types. And so we know it doesn't have the line underneath. Now, since it's shaded below, below means we need smaller y's. And so the smaller y's mean that y needs to be less than. So that's the symbol that we'll use. And then we go ahead and write in the slope. So m is 1/2, and then x, and then it's a positive 1 for the y-intercept, and we're done. There is our equation, or actually inequality in this case. Same thing on the next one. Look for where it crosses the y-axis. 1, 2, 3 spaces up. So there it is, positive 3. So instead of writing y-intercept, I'm going to use the variable they use. B is 3, and then m. Well, my slope, look for where it crosses. So it goes down and then to the right 3 spaces. Down and to the right 3 spaces. So that's what it is, -1 to 3. And then from there, let's figure out which way to shade. It's another dashed line, so it does not have the line underneath. But this time the y values are greater because they're bigger. So this is the bigger y's are on this side. And so we're going to use y is greater than. So the values of y are greater than the slope, -1/3, and then x, and then a positive 3. And that's it. So we've got it. Let's move on to the next one, though. The next one is a different type of line because we don't see the slant of the line. So it's a horizontal line. So what this means is, let's start with our y-intercept. Y-intercept is -2. So we're going down 2. Now what the slope is, you don't go up. You go up 0 spaces. So what we have here is a horizontal line. The slope is always 0. And so now we just need to figure out which way we shade. Now this is below the line. So the y values, which way are they going? They're getting smaller. So these are smaller y's. And so the way we'll write this is that y is going to be less than, but also equal to, because of the solid line. So solid line means we have that or equal to. And then since the slope is 0, we don't have to write that. You could 0x, but 0 times x just makes 0, so it cancels out that x term. And we just have -2, so -2. So this is one way to write it. You could also write it just this way. Y is less than or equal to -2. And that would be our answer. Well, one more problem for this set of directions. And again, we have another solid line, so we know it's going to be either a less than or equal to, or it's going to be a greater than or equal to, just by looking at the line. And so let's go ahead and start with what we've been doing before. The y-intercept looks like it's at +3. But this time our slope is going down and then to the left. So that's the same thing as going up and to the right. So both are positive, but it's just going up to right 1 or down to left 1. So it means our slope is just a 2 to 1, or just 2. Now, we need to figure out which way to shade. We know it has the line underneath, and here in this direction, you look and you see the line, the y values get bigger as I go up this way. They get bigger as I go up here. So we are going towards bigger y's. So we shaded towards the larger y's, so that's why we're using the y is greater than or equal to, and then the slope, 2 times x, and then plus the y-intercept, 3. And there's our answer. Well, that's that first set of directions. After that, you're going to end up having to graph the solutions of each linear inequality, and then they also ask you to check the solutions. So let's go ahead and start by taking a look at that first problem. Y is less than 4 minus x. Well, what they did here is they put it out of order. Typically, they put the x term first. So it's the same as saying y is less than negative x plus 4. So my y-intercept is 4. So I'm going up 4 spaces, 1, 2, 3, 4, putting in the dot, and then using the slope. So here the slope is negative 1 to 1. So down to the right is the direction I go. And I do that a bunch of times so I can draw a line, and I can also go the other direction, up and then to the left. And so I look at the inequality, and it does not have the line. So that's why I have a dashed line. So all that represents is that the solutions are not on the line. They're on one or the other side. And so to figure out which side, you look at the inequality. It's a positive y is less. Less means smaller. So you want to go towards the smaller y's. And so the smaller y's are in this direction. That's the way you'd end up shading, because those y values are getting smaller from the point where it ends up crossing the y-axis. And so this is where we would shade. Well, looking at the next one, we have the same situation, but this time we got a little extra. Got this negative sign in front of the y, so get rid of that. Always isolate the y term, get y by itself, so it just has a positive y out in front. And so we'll rewrite the equation as y is now less than, see, everything changes when you divide by a negative, greater change to less, and becomes a negative 8 plus x. Oops, not plus x anymore, let's fix that. So it should be a minus x because the sign ends up changing. And so positive over a negative makes a negative. Now, if you don't like to see it that way, you can always rewrite the terms. Again, always rewrite the signs in front as negative x minus 8. So there's our y-intercept. Ooh, we got to go down 8 spaces. I'm running out of room. It's going to be way down here. There's like 7. This is 8. And so my line is going to be going down to the right, but I run out of room that way really fast, and so I end up having to go up to the left. It gets me on that line as well. And so from there, I look at the type of line. It's another dashed line. And so that just represents that the solutions are not on the line, but they're on one side or the other. And so the line continues off in that direction, continues off in that one. So I look at it, and it's a positive y is less. Less means, again, below. Below because we're going towards smaller y's. So the smaller y's are way down here, not up here. And so they're going to end up shading down in that direction. Let's take a look at the next one here. Here we got a little bit more work to do. We've got to isolate the y term, so I'm going to subtract that 3x from both sides. And so when I do that, now I'm left with a negative y is greater than or equal to negative 3x plus 4. So from there, one more step. You've got to get rid of that negative sign, just like we did over on this other problem. So I'm dividing by a negative 1. Now when you do that, remember, lots of things change. So everything actually changes. It's now y is less than or equal to 3x minus 4. Watch the signs, they all change. And so now we can go ahead and graph it, starting at that negative 4, that y-intercept, and then using the slope. Slope's 3 to 1, so you're going up 3, so 1, 2, 3 over 1 to the right. 1, 2, 3 over 1 to the right. And you can do that a bunch of times. Get on that line. Now this time we have a solid line through those points, and then we figure out the shading. Now the shading works this way. Positive y is less. Less means smaller. So which way are the smaller y's? Well, here, if I go on this side, you see the y values are getting bigger. So I need to go towards the smaller y's, which are on this side. And so that's why I end up shading below the line. Well, one more problem here, and we'll start with that by isolating the y terms. We have a similar situation here where we need to get y by itself. So I'm subtracting that 2x first. So once I do that, I've still got this negative 3y is greater than negative 2x plus 9. Well, from that point, all I have to do is get rid of that negative 3. So when you do that, you got to divide every number by negative 3. That includes this x term and that constant. So let's see what we've got left over. When I do that division, first of all, got just a y. Remember, you're dividing by a negative, so you got to switch that inequality sign. 3 doesn't go into 2, but this is the slope, so that's okay. Write it as a fraction. If it doesn't go in evenly, just write it as a fraction. And then here, 3 goes into 9 3 times. So negative 3 because it's just the one negative. And then from that point, we'll go ahead and graph. See, we've got a y-intercept of negative 3. So you go down 3 spaces, you put the point, and then follow the slope. 2 to 3. See, it didn't matter that the 3 went into 2 because it's the slope anyhow. So it's a fraction, rise over run. So 2 spaces up, 3 to the right. 2 spaces up, 3 to the right. And then we can go the other way as well, down 2, 3 to the left. Gets us on that line. Another dashed line here because it doesn't have that line underneath. So from there we've got lots of points to represent the line, so we went ahead and drew that, and from there we figure out the shading. So we look at this, it's a positive y is less. So I go to this part right here. Less means below or smaller. So we go towards those smaller y's. Well, which way are the smaller y's? Here the y values are getting bigger as I go on this side. So I want to go towards those smaller y's, which are down here. And so that's why we end up shading in this direction. Well, those are some examples of problems you'll end up seeing on tonight's homework. Part 2 will go over the review section, which involves writing equations and solving systems.